Okay, let's take a look at the solutions to 2025 AP Calculus AB5. This is a particle question. We have two particles, particle H, particle J. We're given the position of particle H and the velocity of particle J. And in part A, they're asking us to find the velocity of particle H. Okay, so in other words, we have to go ahead and derive this function, right? So we're really looking for this. They're asking specifically at t equals 1, right? So that would be 2t minus 4, a little chain rule here, e to the t squared minus 4t. Evaluate that. Well, this is really x prime of t, right? Now let's go evaluate that at 1, and we should wind up getting negative 2e to the negative 3. We could just leave it like that. Particle B says, when are particles H, or question B says, when are particles H and J moving in opposite directions? And in order to really look at that, we're going to have to look at each one of their velocities, right? So let's start with particle A, right? So, and we're gonna really look for when it's equal to 0, right? And so if this is my velocity for particle H, right, only time that could have a critical value is when 2t minus 4 equals 0. So that would be at t equals 2. Okay, so let's test this for a little bit. Now they ask us to confine this interval to 0 to 5, right? So if we just kind of like go 0 to 5, right, and we're really focused in on what's happening around 2, we'll find that the velocity of particle H is negative from 0 to 2, positive from 2 to 5. So here, particle will be moving left. Here, particle will be moving right. Now, meanwhile, right, remember we have the velocity of function j, right, 2t t squared minus 1 cubed. And again, critical values here possibly at 0, which we don't have to worry about, and then plus or minus 1, so we really only have to look at 1. Let's do the same thing here, right? 0 to 5, t equals 1, right? And here, again, negative, positive, right? So particle moving left, particle moving right. So the question is, where are these two particles moving in opposite directions? So AKA, where are their velocities different signs, right? And so we have to look very carefully, but it would have to be between 1 and 2, because here between 1 and 2, right, the velocity of h is negative, but here from 1 on, the velocity is positive. So these particles are going to be moving in opposite directions when t is between 1 and 2. Justification there again is what I just mentioned in terms of velocity being positive versus negative. Let's go to part C. Part C says, is the speed of particle j increasing, decreasing, or neither, specifically at time t equals 2, right? So let's look at this, right? So velocity of particle j at 2 would be positive, right? And now we also have to think about is what is the derivative of that? What's the acceleration doing, right? So what is this sign? Is that going to be positive or negative, right? And so if we were to derive this function also will be positive when we put in 2. And so because both velocity and acceleration of particle j at 2 are positive, the speed is increasing. Okay, last piece of the puzzle is talking about the position of particle j. And so we know some initial information. We know that at time 0, particle j is at position 7, and they would like to know where is the particle at position, or at time t equals 2. And so what we're going to need to do here, right, is say, all right, if you want the position at 2, we're going to need to start with where we are originally, and we're going to need to find the accumulated distance covered by particle j from 0 to 2, right? And we have basically this function to integrate from 0 to 2. So we're going to integrate, right, 2t t squared minus 1 to the third, and that's going to be a quick little substitution, integration by substitution question. Works out nice because if we let u equal t squared minus 1, right, du equals 2t, which is a perfect match. We're not even off by a constant or anything, right? And so the bottom line is we're going to be able to integrate this thing, and it's going to be t squared minus 1 to the 4th over 4, and we're going to evaluate this from 0 to 2. And when all is said and done, we will wind up being at position 27. So there's your solution to AB5 from the 2025 AP Calculus exam. Thanks for watching.